Hi there, my name's Peter Marshall and welcome to this talk called Consider the Broader Ecosystem. This is part of a tips and tricks talk set that have been created by us at Imply to share our experience with those of you who may just be starting out with Druid. And of course, if you've got any questions, don't forget, register on Druid Forum and we will meet you there. What is the broader ecosystem for a Druid application? Well, it contains tools that help us deploy, create, optimize, and operate a Druid-powered application when you go into production. Now, this talk is about 20 minutes long. If you've got any questions, as I said, get into Druid Forum and also talk to other people in the community about what they're doing when they're operating Druid. Through this talk, we're going to come back to this one slide. It brings together the set of the most common technological solutions that community members have found to be useful in their Druid ecosystems. At the top of the card, we've got core processes of Druid and its runtime environment. At the bottom, components that relate to data storage. And in the middle, examples of infrastructure services that can help you use and operate Druid right on into the future. So let's begin our journey with the first set of components that we all learned about when we kicked off Druid. We used the quick start and installed Druid, started the services, we went into the console, loaded some Wikipedia data, ran a query, and went into production. Well, of course, hopefully not. Here's the services that you were all running: the Zookeeper, Coordinator and Overlord, Broker, Router, Historical, and Middle Manager. The Coordinator process leads historicals. The historicals generate statistics from data that they've copied out of deep storage. The Overlord is a leader of middle managers, which are like hungry hippos executing ingestion tasks. Then there's the Broker, divining how to answer queries that we throw at the Druid database. And in Quick Start, you'll have seen the Router running the Druid console, and you'll also have seen Zookeeper, used by Druid for leader elections and general orchestration in this distributed database. One thing you may not have realised following the quick start is that the router does more than just run the console. It can act as an application gateway, providing, say, JDBC connection stickiness. Okay, awesome. Maybe you'll think this is all you need to get your app running, but no, as you know, working in IT, there's always more things to do. You will have realised that Druid doesn't just ingest Wikipedia data. No, there are lots of choices. Apache Druid can connect to streaming real-time sources like Kinesis and Kafka, and to long-term storage like S3, Google Cloud Storage, and so on. I can pull in from HTTP, from relational databases, from local file systems, even another Druid data source. So you may need to take time experimenting with different source file formats and layouts and splits to marry the ingestion tasks with the input format and input source in Druid. You'll also learn that Druid can parallelize ingestion, as middle managers can spawn multiple tasks, with each tasked to ingest a particular portion of your source system's data, and that each of these need to be allocated its own cores and memory. Your next big leak probably comes when you first spin up a cluster. In this instance, you probably used the cluster deployment tutorial, installed lots of Druid services, connected to a metadata database, connected to Deep Store, added a task log store, connected to Zookeeper, tuned the configuration, and then went into production again. Hopefully not. Single server quick start gifts you with standardized configs. But now in cluster quick start, you really need to start to think about your hardware. And one key document here is the Druid tuning guide, walking you through the key options to scale up and scale out your cluster. And it also gives some really critical information about tuning this. Okay, not this. This is the wrong Java. We of course mean this Java, the Java runtime environment. It really is worth checking that tuning guide, even looking at the settings in the different standard Druid configs that come with the distro, so that you can understand what is actually going on. It's the best way to avoid the Another level down when it comes to the JRE are flame graphs, and this is an Imply article free to view when it runs through how to create one and how to understand reading it. At this point, many of us probably started asking, how on earth am I going to manage all the infrastructure for Druid? And when I thought, what server should I run Druid on? I think of a good old compact ProLiant ML370. But of course, things have changed when someone talks about disks that don't actually exist. I mean, what's that about? Never mind CPUs that don't actually exist. And I learned that spinning up a container doesn't mean doing acrobatics with a cardboard box. Are you going to virtualize or will you use bare metal? How are you going to provision and control those nodes that you create? And what networking and HTTP related services might you need? Maybe you need a web application proxy. Maybe you need load balancers. You might choose to use something like Ansible or Puppet or Chef. You could use Terraform. This is a great talk from Athena Health from Virtual Druid Summit 1. And there's also a meetup talk from Saidul Bashir, who is one of the Imply team, and Nicolas Tressignet, who, when they were at Super Awesome, gave this really good talk on using Terraform, Kubernetes, and Helm to deploy to AWS Spot instances. Now, Imply has a tool called Imply Manager. It's our online point-and-click management console, and it allows you to provision and scale out full Druid clusters, whether you're just starting with 5 or you want 1500. It's a really valuable tool to have in your tool belt. Project teams can then speed up different proof of concepts for different use cases, and you can get into production a lot quicker. We invested a lot of time in this to make sure that the configurations that people get for things like the JRE are stable and that they're compliant with the configs. So it really helps you provision and manage multiple high availability clusters and to upgrade Druid in one place. If you want an even more cool experience, of course, there is Imply Polaris, which is our Druid database as a service, with all the tools you need to develop and operate a Druid database in the cloud. Part of that infrastructure you learned in the quick start are compatible metadata database and deep storage services. In single node quick start, this was hidden away from you, where Derby was used locally for a metadata database and deep storage was just in local disk on the node. But now you'll need to decide what you need to use for each of these, and you need to determine how resilient they need to be to mitigate against disaster. And then, like a blinding light, one morning in the shower, you realise you need an application for people to get at this database. Are you going to build something bespoke like Target have? And you can see their video here at Virtual Druid Summit 2. There's this awesome interface built by Game Analytics, and their video is from Virtual Druid Summit 3. And also go and look at what InnoWatts have done. Their video in Virtual Druid Summit 4 is pretty damn good. You might choose to give your users the ability to do things with data science toolsets. So, for example, you might use Druid with Facebook Profit. You see, it's very easy to think, oh, do you know what? I'm just going to swap MongoDB for Druid. But that's kind of missing the point. Imply Pivot is the name of our data exploration tool, and it's built especially for Druid. It's the tool that gives people a real revolutionary new perspective on the data that people put into Druid. It's full of different pieces of information that people can pick and choose from. It all comes together on a single pane of glass where they can slice and dice the data. This is a purpose-built tool where people can explore and visualize the data without using any SQL. They're no longer pinned to pre-calculated statistics. There's no delay between data arriving and it being available for analysis. And then people can go on and socialize their findings with their team. They can come together around decisions. It really helps people come up with recommendations of what they should do. Lots of people have taken Pivot and they've put it into their own online services as well. That really helps them fight the competition. And as you might expect, Pivot has built-in security, making sure that the data people see and the actions they can take are set across the platform. Now, I wrote this post quite a while ago. It's available in Druid Forum just after Virtual Druid Summit 3. And this article summarizes some key qualities of applications that get built on Druid. And it might inspire you and the people you're working with to think differently about the user experience you can deliver on Druid, and not just to swap out an existing solution because Druid happens to be the latest thing on the block. Okay, so we've covered some fundamentals now, but what about really big deployments? What about lessons that have been learned from other users? You might be getting a sense now, like when we spoke about the Java runtime environment and I was talking about the config files, that there is actually quite a lot of different knobs and levers in Druid. As you play with different configurations as well as different ingestion specifications, arguably you need to track what you're doing effectively and check that they're synchronized properly across all your processes. So on the card here, we've got a special block just for config management where you can store and collaborate on and version control those files. Daria Litvinoff, at the end of her Outbrain Virtual Druid Summit 4 talk, spoke about how they are using Jenkins and Git at Outbrain for just this kind of thing. And there's also a brilliant talk by Twitch from Virtual Druid Summit 2. They're again using Git and Jenkins. There's a single place to go in the docs to look at all the configurations. It lists all the levers and knobs you can adjust that you might want to record and to control. With a move to production, you'll also need to think about provisioning and deploying certificates for the TLS communications. You might need an authentication service that works with Druid. You might need some way to authorize access to particular data sources. You might even find that you need to build a layer between Druid and your application, maybe to do things like hashing and masking data automatically. Yes, sorry, you're not just going to have to go and speak to the network team, you're also going to have to go and speak to security and compliance. Take a look at the security section of the docs for a ton of useful information. Now you'll recognize this screenshot, this services tab in the Druid console, and it lists all the Druid processes, but it doesn't list your other dependencies. It doesn't have Zookeeper, the deep store, or the metadata database. So in a production deployment, how are you going to tell if those components, and all the dependencies really, are healthy and okay? How are you going to get alerts? How are you going to get at log files? As your app builds momentum, you're going to need some monitoring. Not just of Druid and all the other components, but also of the flow of data, making sure that you can diagnose where things are getting stuck in the pipeline. To start with, that means these logs. A step very often missed in the clustered quick start is a setup of a long-term storage for your ingestion logs, those things generated by the ingestion tasks. Don't make that mistake. The log files tell you a great deal about what happened at any given moment during ingestion. And you need a common location so that you can diagnose and learn about the ingestion jobs that they run right out into the future. In the task reference in the docs, you'll find a section all about the logs with links to the configuration you need to look at to set up that long-term storage area. You will also have probably spotted some of the most important logs, the logs that are in var SV, generated by log4j2 by each process. A lot of people don't even realize they're there. Maybe they haven't even looked at them, but they're really important, and it's really important you go and understand how to use them. In this snippet from the Overlord and Coordinator log, for example, you can see that the Coordinator was working out whether it needs to rebalance. Not only should you think about where these will go eventually, perhaps for long-term storage, but also think about the configuration you might need to apply to log4j2 in your environment. You can check out the docs to learn more about that. And to properly monitor, you definitely need metrics. Now, Druid emits a lot of metrics. In fact, it's a big area of community development. Make sure you have those set up and emitting, and that you are putting them somewhere. Information about the metrics is in the docs. There are metrics for real-time ingestion, for general health, including the JVM, and for query performance. There are emitters for Graphite, InfluxDB, Kafka, Ambari, StatsD, and Since 022 for Prometheus 2. Whatever you choose, these are really important. They give you the kind of information that is going to make the difference between an okay Druid cluster and one that is highly optimized, one that's constantly improving and being tuned by you to make it more cost effective and performant. At Imply, we developed a UI specifically for monitoring Druid. These are views that operational teams can use to help them keep an eye on health and utilization and capacity and performance. Maybe they can use them to look at different workloads that are driving usage, or to pinpoint some process or other that's causing performance issues. Very often they're using it to just help make sure they're getting as much value as they can out of using Druid. Okay, so that's monitoring. Now let's return to ingestion for a moment. Ingestion jobs can be submitted via an API, and using that API is critical for any ingestion that you need to do repeatedly, say a regular batch ingestion. The console isn't there for version control either, so those APIs and this tooling gives us a way to attach a mature tool for continuous development. And a very popular tool is Airflow, so have a look at this Avesta Technologies Druid meetup video. And as a bonus, there's a second talk from me about POC gotchas. And while it's a few years old now, there's a blog by Simon Spatey who, when at Rhodes Schwartz, wrote an article on this architecture. But data from producers is never exactly as you and I want it. And even when it is how we want it, you might still need to do other treatment. You might need to intercept the data on the way to a database, create separate sources. You might just update what's in the source data itself. To build any application, it goes without saying that we need to prepare data ready for any database. It has to be ready for analytics. It's worth checking out community videos and articles on how you should use data processing to help you lay out and treat your data for optimal use with Druid. One area, for example, may be upstream sessionization if you're doing clickstream, or flattening complex data in an IoT use case, or making sure that incoming splits of data are well balanced for ingestion tasks. Now on to some elements that affect querying data. When segments are pulled into historicals from deep storage, they arrive in the local segment cache on the local disk on the machine. And I can't tell you how many times I've met someone who didn't know that the size and the location of this cache was configurable. I even met someone who thought that Druid was limited to just 300 megabytes. And you'll also know that it needs to be on fast disks, on SSDs. Also, sometimes missed is that Druid uses OS-level memory mapping, allowing for those segment files to be opened and processed intelligently in memory and then held there for reuse. Some community members have designed their cluster so that there is a 1-to-1 ratio between the segment cache size on the local machine on the historical and the memory available in that machine. Why? Because it helps minimize the risk of eviction. Think about the local historical segment cache size that you set, the OS memory available for memory mapping, and use the metrics to look at your query patterns. And on caches, there's also query time caches in Druid. There are some deployments where people have taken this into a dedicated cache system and out of the nodes. Now that's quite unusual, but it is possible. Again, go and consult the documentation. It tells you about the different cache types used when queries execute, whether they're per segment or whole query, and it gives you links to data level caching information on the historicals. Again, go and have a look at these awesome docs. So here we go then, our completed card of things that people need to think about when you go forward in your adoption journey with Druid. At the top, core Druid services. At the bottom, services you need for storing data. And in the middle, some infrastructure services. If you've got any questions about what you've seen today, do register on Druid Forum, raise a question, and look through the huge library of articles and videos that you'll find there. Don't forget, say hello to us, we'll say hello to you. Visit learn.imply.io for Druid-related courses, and with me, please do say thank you to the developers behind Apache Druid by putting a star on the Apache Druid GitHub repo. Thanks for watching.